Hello, everyone. I'm Alex. Today, I'm gonna tell you a story about our ISO 27001 journey. When I built infrastructure for a startup and eventually had to get it certified. So this is a story about it. How it started. I began to work with a company, startup company, very young. I think it was 3 months old when we got together. They were a talented bunch of ML engineers who had an idea about their product, but infrastructure is something boring, and this is what I signed up for doing. And I always liked this concept of infrastructure as code, and I saw its potential, and for me, it was interesting to implement it, so I did it. I did it with GitHub on top of AWS, and I had to get it certified. For a startup, the most critical feature is velocity, right? Because if you don't move fast, your startup dies. You're late with the product, so velocity is a deal breaker. And on the other hand, I wanted to get things right and implement everything properly and securely. And I think I managed to strike a balance between staying fast and making sure that the infrastructure is compliant. So I will show you what we came up with. So even before the product launch, the company started talking to enterprises. They pitched the idea. And one of the potential customers was a big public company, unicorn. And they were like, OK, guys, if you can do POC, if it works, we will give you some business. And they did it. The POC was successful, and the company started talking about the contract. And of course, security legal compliance team joined the conversation, and they asked, do you have any certificates? Are you secure at all? And the founders came to me with that question, and I was like, I don't know. I put my best knowledge and experience into this infrastructure, so I think it is secure, but don't take my word for granted. Let's hire auditors, and let's commit to get the certification. And I also had my selfish interest here, because if I did something wrong or if I missed it, I wanted to know that from auditors, not from hackers. So we started talking with auditors, and they suggested an option between ISO and SOC 2. And we opted for ISO because SOC 2 Type 1 and ISO 27K are almost identical, but ISO is more international, so we decided to go with ISO. And why do you need compliance at all? Why do you need to get certified? Especially if you work in B2B, it's not even an option. You have to be compliant, because for enterprise customers, it's a deal breaker. You have to be compliant, you have to be secure in order to get the deal. And even if you are compliant, if you have the certificate, the customers will send you vendor assessment forms anyway. And if you've seen those, this is a screenshot of one of them, 143 questions. Those are nightmares, and they ask you to fill them out anyway. The good news is many of these questions are copy-paste from ISO controls. And if you are certified, you know the answer to those questions, so it's a simple copy-paste job. And the reason why the customers do that, I believe there are two reasons. One reason is, let's say not all certifications are as thorough as they're supposed to be, right? Especially internet is full of ads, compliance in 6 weeks, and clients know that. And that's why they require not only the certificate, they require supporting documents that you would submit when you got certified. And another reason why they do it, I believe, is because legal reasons. They try to put more responsibility on you. They try to put more liability in the contracts, right? Because otherwise it's just certificate, it's a promise that you have policies, that you follow those requirements, but it's not a contract, right? So customers ask that. I believe that you should start as soon as possible. And the reason for that is because there are some decisions that it's easy to make but difficult to change. I worked for, before all this, I worked for big companies, public companies, and I remember when I joined the company, there was a dev-prod separation project, and that project wasn't done when I left the company. And I was 5 years with that company. It's very difficult to separate environments if they are not separated from the very beginning. Another reason is it takes time. It takes time to implement everything, and when customers come to you and they're ready to sign the contract, but you're not compliant yet, and they ask for compliance, okay, it takes 13 months to get certified. Of course, it's a problem. Okay, how to do that? Infrastructure as code, I believe, was the single principle that allowed me to get it implemented fast, reliable way, and pass audit easily. Basically, what it was. Infrastructure as code means there is code. All this story starts with GitHub, where you store code not only for applications, but for infrastructure, for configs, for nearly everything. So this is like reference architecture. I tried to squeeze as much as I could in the picture and not miss anything. I hope it's readable, but let me read about it. So GitHub becomes storage for the code, but also it is an engine for access management, change management, for CI/CD, for applying changes. GitHub, using OIDC, gets authenticated in AWS. And AWS part, first of all, Control Tower, very good tool for compliance. From the very beginning, we separated environments in different accounts. So production environment and sandbox environment, development environment were separate AWS accounts. For big customers, I created dedicated AWS accounts in Control Tower. It's easy for access control. It's also easier for cost management. You understand how much does it cost to run this customer. Control Tower itself provides SSO that allows to distribute roles to developers, and those roles have temporary credentials, so you don't end up with the situation when permanent AWS API keys are stored locally and then get stolen by light LLM or whatever. Okay, what else I missed here? Security Hub. Security Hub was a big thing, especially for security objectives. ISO requires for the organization to have security objective, and we used it as a key result to measure our security posture. Traditionally, even our auditors came in and they suggested, let's have number of security incidents per quarter as a metric. I didn't like that metric at all. I didn't like it, again, from previous companies when we had similar metric for number of reliability or availability incidents. And then instead of fixing the problem, teams were arguing about, oh, it's not an incident, or yes, it's not our incident. I think incentive works, and you have to set right incentive. So Security Hub runs a number of checks against your infrastructure and gives you a score. So that score kind of represents how good your security posture is. This box, Vanta, probably deserves much bigger box because it was our platform for compliance. It was difficult to collect and aggregate all information related to ISO. ISO itself is not only technical implementations of your infrastructure, it's also policies. It also includes processes like access control and vulnerabilities. And Vanta, really good product, highly recommend. It aggregated all of that and gave you good visibility on where you are, what's not fixed yet, what's still to do. And for ongoing maintenance of the certification, it's also quite convenient. For example, you need to do quarterly, let's say, regular access control reviews. And that's one of the tools, one of the features that is included in this platform, very convenient to use, and practically helps a lot. When we do a quarterly access review, we find some accesses that expired. We don't want them to be there anymore, so it's a useful tool. All right. Okay, vulnerability later. I will cover that. So, almost all of the infrastructure is described in Terraform. It's InfraHouse itself. We built a lot of infrastructure components that allow to deploy with Terraform pieces of infrastructure. On this slide, there is a snippet, code snippet, how you deploy ECS service from a Docker image. So how it works is developers write the code. The outcome of their work is piece of software that is packaged in a Docker image, right? The next step is you take this Docker image, basically this line, and you deploy it in ECS. ECS, AWS as a service. Anybody can do it. Anybody can copy-paste this piece of code, change Docker image, change port, subnets, and get online very quickly. Another important benefit of this approach is that it is reproducible. And if you change anything, GitOps allows you to see the history of changes, audit trail. This is something that auditors are happy about. And of course, approvals, etc. Okay. This Terraform change is incorporated in the CI/CD pipeline. So the way it works is anyone who has access to GitHub, to a specific repo, creates a pull request. GitHub Action Runner then runs Terraform plan and summarizes the plan in something like this. In this specific example, I deploy OpenClaw, right? So the plan suggests I create 14 resources, some change, some get destroyed. Important part is that this pull request has to be approved. And then when it is approved and merged, CD part kicks in and actually runs Terraform apply that deploys this piece of infrastructure. So the same workflow works for access control, right? So there is a access configuration described in the code, and any change, new access, new user, change in the access gets through the pull request workflow. This is kind of simplified version of it, but basically, this is a configuration for AWS SSO. In here, you define groups, what permissions those groups have, and for users, for individual users, you assign them to groups so they get those permissions. Very easy to audit, very easy to maintain, and again, very compliant because there is a request, there is approval, and there is an audit trail. Change management, if you make a change to the infrastructure, looks exactly the same. Pull request, approval, merge, CD apply. Yeah, this time the change was much smaller. Only 2 resources have changed. Okay. Vulnerability management is a big part of the compliance story. And there are many actions that you need to do for vulnerability management, and one of them is you need to regularly update AMIs because in this specific example, we use AMI to run ECS service, and Amazon releases security patches in new AMIs, and when there is a new AMI, you need to use it. So we configured Renovate tool, yet another very useful tool, to keep track of latest AMIs. And if there is a new AMI version, like here, Renovate created a pull request for the change, and this pull request got reviewed and merged. That way, we removed some of vulnerabilities from our production system. For non-container workloads, which we have a few, like VPN server, Elasticsearch server, and some others, Canonical provides Ubuntu Pro service for free if you run it on EC2. Okay, so Canonical provides Ubuntu Pro service that you can potentially purchase. But if you run your workload on EC2, those EC2 instances are free. So why not use them? I do. And if you use those instances, you can use ESM repos, and Canonical publishes security patches in these repos. So again, you can get vulnerabilities fixed fairly easily. Another problem that we had to solve is monitoring and alerting. Let me explain. ISO controls requires that you monitor your infrastructure, right? For example, if you have a Lambda server, a Lambda function, you need to monitor error rate of this function, right? To make sure that it doesn't fail silently. Or if you run a load balancer, you need to monitor this load balancer. So if you package a piece of infrastructure in a Terraform module, you can collocate resource and its monitoring into one piece. In other words, when I create a load balancer, right next to this load balancer, I create all necessary alarms to monitor this load balancer, or Lambda function for that matter, the same story. That way, you know, when you create something new, it's not missed. Our original approach was like to create alarms later, but it didn't work well enough because next day somebody created new service and alarms were not created for it, so it created monitoring gap, which is not good. Again, using Terraform modules helps to prevent that situation because, again, if you create load balancer, you create alarms automatically, and you covered. Okay. So Control Tower is a AWS service that allows you to create multiple AWS accounts, but not only create them, it allows to establish controls and policies on those accounts. Plus, it comes together with other AWS services like AWS config, and when you configure CloudTrail, when you configure Control Tower, it enables CloudTrail for you, which is very helpful not only for compliance purposes, but also for debugging permissions, troubleshooting, postmortems, what happened to that S3 bucket, et cetera, et cetera. All right. Security Hub. Security Hub is also can be enabled on organization level, and the way it works, it uses AWS config to gather AWS configuration across different accounts and match it against AWS control rules. All of that information is gathered in one place in your management account or delegated admin account. And in Security Hub, you can see all these controls, and if there are any failures, you can see it as a number and red color. For example, if you have, I don't know, S3 buckets with public access, you can see that problem in one place. And we actually put this number in OKRs, this security benchmark score. We increase a little bit the target with every quarter, and we hunt the problems until we're happy with the result. At this point, there are a few low-level checks that we don't care about much, like, I don't know, support contact is included. So not big deal, but we know that all important things are enabled, they are constantly monitored, and we got them. Guard duty and AWS Inspector. Especially the AWS Inspector is a useful tool. We use it for vulnerability management. I'll talk about it on the next slide. Guard duty is useful for threat detection. If somebody, I don't know, used unusual API call or uses AWS from unusual location, or there is some scanning activity, Guard duty detects that and notifies you about that. Quite useful for prevention. AWS Inspector is a part of vulnerability management, and how much time do I have? Okay. Vulnerability management, probably the biggest part that you need to deal with. I like to think about vulnerability in production as a mini incident. And I apply incident protocol to vulnerabilities. What it means is I want to prevent vulnerabilities. To prevent vulnerabilities, I scan pull requests when they arrive to GitHub. I use OSV scanner for dependencies. If some software uses a vulnerable dependency version, OSV scanner highlights that, and I can take an action. Either require upgrade or allow security extension if the risk is acceptable and we can fix it later. Trivi is a similar tool. We use it for Docker image scanning. Same purpose, but Trivi detects vulnerabilities in packages, operating system level packages, and inside dependencies inside the image itself. Now, detection is when vulnerability is already in your production. Why it can happen? Because yesterday there was no vulnerability, today the vulnerability is discovered, and here you go, vulnerability in your production. AWS Inspector scans EBS volumes and Docker images in the ECR repo. And if there is a vulnerability, it reports it to Vanta, and Vanta highlights this as a finding, and this is where notification kicks in. So the way it works, we have vulnerability sources. Dependabot, AWS Inspector. All of this information is gathered in Vanta, and we read Vanta, and if there is a vulnerability, we create linear ticket for a developer. Or if vulnerability is closed and there is an open linear ticket, we close the linear ticket. So it helps with automating vulnerabilities. There is a lot of vulnerabilities coming in every day. I don't know. If you don't automate this, it's very difficult to keep up. For remediation, we actually employ a little bit of AI. We get information from AWS Inspector on remediation suggestions, but also we ask LLM, how would you fix this problem? And we include that in the linear ticket with the suggestion about how to remediate this vulnerability. Then developer can implement that in a PR, that it gets merged, and then vulnerability fixed. For ECRs, the image is not vulnerable if it's deleted, right? And we put a lot of effort in deleting all images that we don't need to make sure that there are no vulnerabilities discovered by AWS Inspector. We had to implement a little bit sophisticated logic on top of standard lifecycle policies that ECR itself provides. For example, if the Docker image was ever successfully deployed to production and it was running, we mark it as a rollback candidate, just in case we want to roll back anytime. And we keep a number of these rollback candidates in the repo. Otherwise, we aggressively delete all images because deleted image is not vulnerable image. All right, so the audit part was the most boring part ever. There are two stages. Turns out I'm on call. For ISO, there are two stages. One is external auditors review your policies. You provide a bunch of different policies, 94 controls, and they review the policies to understand whether they make sense, right? For example, if you put something like, we accept critical vulnerabilities, which in theory you can make policy like that, but auditors will turn down this policy because it's not good policy. So this is stage one. They review your policies, whether they make sense or not. Then if they do, there is a stage two. The stage two, they actually gather evidence. You provide evidence about how you segregate environments, how you do access management, how you do change management, all those pull request screenshots that I showed before. They review this, and if everything looks good, they give you a PDF like this. Very satisfying to see it. All right, and yeah, what I learned. First of all, velocity is possible with infrastructure as code. Second is Venta, very useful tool for compliance, maintaining compliance, getting compliance, because it helps to organize data. Some tools I would not recommend because I had some difficulties. For example, OSV Scanner is an open source tool that uses the same database of vulnerable dependencies, but it also allows to file exemption, temporary exemption, and give time developer to fix the vulnerability later, because you have SLA. And the vulnerability, low-level risk, so you can do it. Sentinel-1 we used for scanning activity on EC2 instances, and honestly, it was too noisy to be useful. I don't know, this is still in process of like what could be more efficient, but I wish it wasn't that noisy, and false positives are like Puppet runs first time on the instance, and Sentinel-1 is not happy about it because Puppet installs a package, okay? So, anyway, that's all I had for today. Do we have time for questions? Do we have 5 minutes? Wow, perfect timing. Any questions about this? Okay, I take it as a no. Good? Yeah. Oh my, thank you.